AQA Practice Set 1, Paper 3 Calculator. Question 1. Circle the inequality shown by the diagram. The closed circle on -7 means that 7 has to be included, which would automatically rule out these two options here. The open circle at 6 means that 6 is not being included, which would rule out this option, so the answer is x is less than 6, x is greater than or equal to -7. Question 2. The probability that a biased coin lands on heads is 2/3. The coin is spun twice. Circle the probability of 2 heads. So if we were to draw out a tree diagram here, which we could do because there is space below for working, and just because these are multiple choice questions doesn't mean that we don't have to do working or that we should be able to necessarily get the answer straight away. We may have to do some working. So in the first coin flip, the probability of heads is 2/3, tails 1/3. For the second flip, the probabilities remain the same. We're using the same coin. Each flip is independent of the previous flip. Now the probability of 2 heads means we follow this path here, so we need to do 2/3 multiplied by 2/3, which is 4/9. So it's this answer here. Question 3. Water is poured into a glass for 4 seconds. The graph shows the depth of water in the glass. What is the rate of change of the depth of water? Now the rate of change is the gradient of this graph. So if we look at this right angle triangle here, the change in the y coordinate is 10, the change in the x coordinate is 4. Now we know the gradient is equal to delta y divided by delta x, which is 10 divided by 4, which simplifies to 2.5 centimetres per second. The ratio of x to y is 2:3. Circle the correct statement. This question is set up to be a little bit of a trick because a lot of people will add together the two parts here, 2 and 3, and get 5, and decide that x is 2/5. X is 2/5 of the total, and y is 3/5 of the total, but this is not what these phrases refer to. These phrases are looking at the proportion of x or y in relation to each other. If we draw this out visually, x represents 2 parts of the whole and y represents 3 parts. Now, x, if we shade x onto the y diagram, we can see that 2 parts of y are shaded, i.e. 2/3 of y corresponds to the same as x, which means that x is 2/3 of y. As you can see, y is 3 boxes, and we've shaded 2 out of 3 of those y boxes. Question 5. Factorise fully 9a squared minus 6a. Looking at the 9 and the 6, we can take out a common factor of 3. A squared and a, we can take out a common factor of a, leaving us with 3a subtract 2. Always check by expanding. 9a squared minus 6a is the correct answer, is the correct starting point, so we can fill this in our answer space, 3a brackets 3a minus 2. Question 6. Work out the next term of this quadratic sequence. Read the question carefully. It says next term. It does not say work out the nth term, and this question is only worth 2 marks. It's a quadratic sequence. Let's look at the first layer of differences. We have +8, +12, +16. Naturally, the first differences are all different, but they increase by 4 each time, so the second differences are 4. So if we add 4 to 16, we get 20, which means that the next term will be 20 more than 40, it will be 60. Question 7. Here is an ordinary dice. Ali is going to throw the dice 6 times. He says, I will get 1 of each number. Give a reason why he could be wrong. There are a number of ways in which we could explain this. One way in which we can explain this is that this is an experimental result. It's not theoretical. Each number has a 1 in 6 probability of occurring, and it is possible for more than one number to come up more than once. experimental results will not necessarily reflect exactly what happens in theory because these results are random. So it's possible for a number to come up more than once. 7 Part B. Lucy throws the dice 50 times. Her results are shown. Work out the relative frequency of throwing an odd number. So the relative frequency of an event is equal to the number of times the event occurs divided by the total number of experiments or trials. So odd numbers are 1, which happens 7 times, 3, which happens 12 times, and 5, which happens 9 times. 7 plus 9 plus 12 comes to a total of 28. So an odd number comes up 28 times out of 50 possible throws of the dice, which we simplify to 14 over 25. We weren't asked to simplify, but we may sometimes be penalised if we don't simplify, so it's important that we do that where possible. Question 8. Polygon ABCDE is divided into triangles as shown. Use the triangles to work out the sum of the interior angles of polygon ABCDE. You must show your working. There's a temptation here to try and say that this is a right angle. We don't know that. It might look it in the diagram, we don't know that. The same with this angle here, BAE. We do not know that this is a right angle, even though by appearances it may feel like it. We cannot make that assumption. Now, angle B plus this angle here plus this angle here must be equal to 180 because the angles in a triangle add up to 180. This angle and this angle and this angle also add up to 180. And finally this angle and this angle also all add up to 180. This covers all of the angles inside the polygon. So the total of the angles, because this shape can be split into 3 triangles, must be 3 multiplied by 180, which is 540. Question 9. In a school, 60% of the students are girls, which means that 40% are boys. 50% of the girls walk to school, 20% of the boys walk to school. So 50% of 60% is 30%, and then 20% of 40%, so this was the girls and this is now the boys, is equal to 8%. If we're not sure about where that came from, think about 10% would be 4, and then 20% would be 8. Now the total of 30 plus 8 is 38, so the final answer is 38%. Question 10. The graph y equals a plus bx minus x squared is shown. Question 10, part A. Circle the coordinates of the turning point of the curve. Now the turning point of the curve is this point up here, which we can see has coordinates 2, 16. So the answer to part A, 2, 16. 10 part B, circle the value of A. Now if we look at the equation of the graph, A will represent the y-intercept. Now we know this because if x is equal to 0, this is always where a graph will cross the y-axis. If you look at the y-axis, every single coordinate on that point has an x-coordinate of 0. If we substitute x equals 0 into this, we have a plus b times 0 minus 0 squared, which of course simplifies to a. So the y-intercept is a, the numerical constant term at the end of this function. So we can see that the value of a has got to be 12. Part C. circle the two roots of a plus bx minus x squared equals 0. Now the roots are where this graph crosses the x-axis, so here and here, so the answers are -2 and 6. So 10 part C from the previous question, -2 and 6. Question 11. Adam and 6 other men ran a race. The time in seconds of the other 6 men are shown. The mean time for all 7 men was 9.83 seconds. Did Adam win the race? So we're going to work out the total time for the 7 men, the 6 and Adam as well, which must be 9.83 multiplied by 7. This comes to a value of 68.81. We're now going to work out the total time for the 6 men, i.e. not including Adam, which of course is the total of these times over here. So we're adding together these 6 values. This comes to a total of 59.14. This means that Adam's time must equal 68.81 subtract 59.14, which equals 9.67. Now this is less than all of the other times on the list, so Adam's time is the lowest and he wins the race. Question 12. The diagram shows a square. Work out the length of one side of the square. Now there's a temptation here to multiply the two side lengths together to work out the area, but we have no information about area at all, and it's irrelevant in this case. What we do know is that the two side lengths have to be equal, so this allows us to set up a very, very simple equation. 7x minus 3 equals 3x plus 1. Expanding the bracket here, 3x plus 3, we can now solve a very, very simple equation. Add 3 to both sides, so 7x equals 3x plus 6. Subtract 3x, so 4x equals 6, and then divide by 4, giving us x equals 6 over 4, which is 1.5 centimetres. A lot of people unfortunately then stop at this stage, but we have not finished because the question asks us to work out the length of one side. So we have to substitute 1.5 back into one of the side expressions, which will give us 3 multiplied by 2.5 here, which is 7.5 centimetres, and that is the answer to this question. Question 13. A circle has equation x squared plus y squared equals 4. Calculate the length of its radius, or circle the length of its radius. The equation of a circle is x squared plus y squared equals its radius squared, so the radius squared must equal 4, which means the radius is 2. Question 14. A, B and C are different prime numbers less than 20. A equals the root of 4b plus c. Work out two possible sets of values of a, b and c. So we're going to list all the prime numbers less than 20. 2, 3, 5, 7, 11, 13, 17 and 19. So we can choose from these. A, B and C are all different to each other, so within a set of numbers A, B and C have to be different values. Work out two possible sets of values of A, B and C. There are a few different options which work here. For example, if we choose b equals 2 and c equals 17, then we have the square root of 4b, which is 8, plus 17, which gives us the root of 25, which gives us 5. So a must equal 5, b must equal 2, and c must equal 17. Another possible option is if b equals 3 and c equals 13. This gives us the square root of 4 lots of b, which is 12, plus c, which is 13, which again gives us the root of 25, or 5. So A is 5, B is 3, and C is 13. Another possible option, if B is 11 and C is 5, then we have the square root of 44 plus 5, which is root 49, or 7, in which case A would equal 7, B would equal 11, and C would equal 5. Question 15. Simplify fully 8x cubed y to the power 5 all squared. The simplest way to ensure that you do not make a silly mistake with this is to write out what you are working out. That's 8x cubed y to the 5 multiplied by 8x cubed y to the power of 5. This is a cube here. So, looking at 8 first of all, 8 multiplied by 8 is 64. Looking next at x cubed multiplied by x cubed, that would give us x to the power of 6. And then finally, looking at y to the power 5 multiplied by y to the power 5, that's y to the power of 10 overall. Because we're multiplying, we add our indices. Question 16. The diagram shows a lawn with a fence along one edge. One can of weed killer costs 90 square metres, each can costs £19.25. Work out the total cost of the cans of weed killer needed to cover the lawn. So, we need to work out the area of this shape here. It's a trapezium. There's a very common misconception here, and it's incorrect, where people try and assume that the fence is also 12 metres and that this is part of a square. It's not. Draw in this line here, which is the same length as and parallel to the fence, and we create a right angle triangle. This distance from here to here must be 12, and because the total distance along the base is 20, this portion, the base of the triangle, must equal 8. So, to work out the length of the fence, we apply Pythagoras Theorem. X squared plus 8 squared equals 17 squared, which means that x squared is equal to 17 squared minus 8 squared, which is 225, which means x is equal to 15. Mark that on the diagram so you can see it clearly. We now need to work out the area of the trapezium, which we know is half the sum of the parallel sides. The parallel sides are 12 and 20 for the whole of the base, multiplied by the distance between them, which of course is this 15 along here. So multiplied by 15. This comes to a value of 240 metres squared. We know one can of weed killer covers 90 square metres, so we need to work out the number of cans needed, which of course is 240 divided by 90, which works out to be 2.6 recurring. We can't buy 2/3 of a can, so we need 3 cans. Now, each can costs £19.25, so we need to work out 3 multiplied by £19.25, which comes to £57.75. Question 17. Expand and simplify this pair of double brackets. So, multiplying out the brackets, 2x multiplied by 3x is 6x squared. 2x multiplied by negative 8y is negative 16xy. Plus 5y multiplied by 3x is plus 15xy. And 5y multiplied by negative 8y is negative 40y squared. So the final answer is 6x squared minus xy minus 40y squared. Question 18. The ratio of the number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls at the party is now 5 to 8. Work out the number of girls at the party. So, boys to girls, this ratio of 3 to 4 we can also think of as a ratio of 6 to 8. So before the boys left, we had 1, 2, 3, 4, 5, 6 parts representing the boys, and 1, 2, 3, 4, 5, 6, 7, 8 representing the girls. Afterwards, the ratio is now 5 to 8. So we have 1, 2, 3, 4, and 5, and we have 1, 2, 3, 4, 5, 6, 7, 8. We know the number of girls did not change, but the number of boys did change because initially we had 6 parts and we ended up with 5 parts, which means that this one single part must represent the boys who left, which is 6. So each box is worth 6. The girls represent 8 boxes. 8 multiplied by 6 is equal to 48, which means there were 48 girls at the party. Question 19. In the UK in 2000, 25% of the population were under 24 years old. This means the lower quartile is 24. 50% of the population were under 37 years old. This means the median is 37. And the interquartile range of the ages was 32. The interquartile range is the upper quartile minus the lower quartile, which means that the upper quartile must equal 32 plus the lower quartile of 24, which gives us 56. So we need to draw this on our box and whisker plot. So the median, first of all, is 37, which is approximately here. The lower quartile is 24, which is approximately here. And the upper quartile is 56, which is here. And then we can draw in, neatly, using a ruler, the box and whisker part, the box part of the box and whisker plot. The oldest person was 107 years old, so we can add that to our diagram as a whisker at 107. And we haven't been given any information about the youngest person, but we'll take the low whisker down to 0. Then join these up neatly using a ruler to create our box and whisker plot. 19 Part B. It is predicted that in 2050 the age distribution in the UK will have lower quartile 26, median 44, upper quartile 66. Make 2 comments about the predicted change in the age distribution in the UK from 2000 to 2050. The key things are we need to compare the median and the interquartile range. The interquartile range for 2050 is 66 minus 26, which is a predicted interquartile range of 40. So we can see that the original median was 37. The new median is 44. So the median has increased by 7, which suggests on average, the average age will have increased. The second comment is going to compare the interquartile ranges, and we can see that the original interquartile range was 32. The new interquartile range is 40, which means the interquartile range has increased, which suggests that there is greater spread in the central 50% of the ages. Question 20. An amount of money was invested for 8 years. It earned compound interest at 2.5% per year. After 8 years, the total value of the investment was £11,696.67. Tom is trying to work out the total interest earned, using this calculation here. State what is wrong with Tom's method. There are a number of different factors incorrect with this method, one of which is that this isn't compound interest, he's attempting to work out simple interest. If it were any kind of attempt on compound interest, he would be multiplying by 1.025 and raising it to the power 8, not by 0.025 and multiplying by 8. So there are a number of possible ways of explaining why his calculation is incorrect. 20 Part B, work out the total interest earned. Now, we do not know how much money Tom began his investment with. We know that he invested an amount of money for 8 years, and after 8 years the total value of the investment was this number here. So this is a reverse percentage type question. We know that he started with a value of X pounds and he invested it at a rate of 2.5%, so our multiplier is 1.025, over a period of 8 years, and as a result he earned this amount of money. So to work out his starting amount of money, we have to do the final amount of money divided by 1.025 to the power of 8. This comes to 9,600.0017 ... But the question actually asked us to work out the total interest earned, not the starting amount of money. So if we take the final amount of money in the account and subtract from that 9,600.0017, that gives us the interest, which is £2,096.67. So that is our final answer to the nearest penny. Question 21. Mersenne primes are prime numbers that can be written in the form 2 to the n minus 1, where n is a whole number. For example, 3 can be written as 2 squared minus 1. Prove that 2 to the 9 minus 1 is not a Mersenne prime. So 2 to the 9 minus 1 is equal to 511, and 511 is actually equal to 7 multiplied by 73, which you can work out by testing 511 for divisibility and cycling up through numbers. 7 times 73 is 511, i.e. 511 is not a prime, let alone a Mersenne prime. Question 21, part B. There are Mersenne primes when n equals 5 and n equals 7. Anna says the ratio of the indices is 5 to 7. This means the ratio of the Mersenne primes is also 5 to 7. If we work out 2 to the 5 minus 1, that gives us a value of 31. If we work out 2 to the 7 minus 1, that gives us a value of 127. So the ratio of the two Mersenne primes is 31 to 127, and this is not a ratio of 5 to 7. These two numbers do not simplify to give us a ratio of 5 to 7. Question 22. Work out the value of y in this triangle. This is a very, very simple case of the sine rule. We have opposite pairs of angles and sides, and we're trying to find a missing side. So sine A over A equals sine B over B, or A over sine A equals B over sine B. We're going to use this version here as we're looking for a side. So effectively this is A and this is capital A, this is lowercase b and this is capital B. So we know that y divided by sine 35 equals 15 divided by sine 70. Now rearranging this, y is equal to 15 over sine 70 multiplied by sine 35, which comes to a value of 9.1558, which is 9.16 centimetres to 3 significant figures. Question 23. 2x squared minus 20x plus c is equivalent to a bracket x minus b all squared plus 3b. This symbol here means the left and the right hand sides are identically equal. This is identity. So in a much simpler example, if we had 3x minus 4 is identically equal to px plus q, then we can see that p would have to equal 3 and q would have to equal negative 4. To work out the missing values, we're going to start by expanding x minus b, all squared. So this gives us x squared minus 2xb plus b squared. We have to do some simplification to get there, but that is the correct expansion. Now this is being multiplied by a, so each part of this expansion has to be multiplied by a, which gives us ax squared minus 2abx plus ab squared. So we now know that 2x squared minus 20x plus c is identically equal to ax squared minus 2abx plus ab squared, and then don't forget this plus 3b at the end. Now, if we compare the parts, 2x squared and ax squared must be equivalent, so a must equal 2, which will be useful in a moment. Negative 20x must equal negative 2abx, which means that negative 20 must equal negative 2ab, or 20 equals 4b, as a equals 2, so b must equal 5. This is going to be useful in the last part to find c, because c must equal ab squared plus 3b. So that's 2 multiplied by 5 squared plus 3 multiplied by 5, which is 50 plus 15, or 65. So c equals 65. Question 24. A, B, C, D are points on a circle. Angle ABC is 92 degrees, ACB is 38, ACD is 50, and CDE is 32. Tick whether each statement is true or false, giving a reason for each answer. So statement 1 asks whether AC is a diameter. So if we look at AC and go up to the circumference of the circle at B, this angle here is 92. If AC were a diameter, then it would split the shape into two semicircles, and we know the angle in a semicircle has to be 90 degrees. This angle is 92 degrees. So the answer to the first part of this question is false. AC is not a diameter because the angle in a semicircle is 90 degrees, and this angle, ABC, is 92 degrees. The second statement asks us to decide whether it's true or false that angle ADC equals 88 degrees. So angle ADC is this one over here. Now, we have a circle, points D, C, B and A lie on the circumference of that circle, generating a quadrilateral ABCD, which means that ABCD is a cyclic quadrilateral. The opposite angles in a cyclic quadrilateral add up to 180 degrees, which means that this angle over here is equal to 180 subtract 92, which is 88 degrees. So the statement is true, and our argument is that opposite angles in a cyclic quadrilateral add up to 180 degrees. We do not write that they equal 180 degrees, we write that they add up to 180 degrees. Statement 3. ABCD is a trapezium. Now, if we work out the size of this angle here, angles in a triangle add up to 180 degrees, so 180 minus 92 minus 38 gives us a value of 50, so this angle here is 50, as is this angle here, which means we have a pair of alternate angles. We have to use the correct phrasing, alternate angles, which means that this line AB is parallel to this line CD, and a trapezium only needs to have one pair of parallel sides, or a trapezium only has one pair of parallel sides, which means that ABCD is a trapezium, which means that the statement is true. Statement 4, DE is a tangent to the circle. Now, we know that this angle here is 88, angle ADC, and because ACD is a triangle, we can work out the size of this angle over here, which is 180 minus 88 minus 50, which comes to 42 degrees. Notice that the 42 degrees here is not equivalent to the 32 degrees here. If DE were a tangent by the alternate segment theorem, this angle here, EDC, would have to equal this angle here, angle DAC, the angle in the alternate segment. They're not equal, which means the theorem doesn't hold, which means DE is not a tangent. Here are the written statement answers to this question. So angle ADC equals 88 degrees, absolutely correct, it's true. Opposite angles in a cyclic quadrilateral add up to 180 degrees, and 180 minus 92 is 88 degrees. Statement 3, ABCD is a trapezium. True. We know that angle BAC is equal to 50 degrees. Angles in a triangle add up to 180 degrees. So angle ACD equals angle BAC equals 50 degrees. We have alternate angles which are equal, which tells us that AB is parallel to CD, so we have a quadrilateral with one pair of parallel sides, which is a trapezium. Finally, the last statement, DE is a tangent to the circle, false, and our reason for that is that angle DAC is equal to 42 degrees, not 32 degrees, i.e. the alternate segment theorem does not hold. Question 25. A formula connecting speed, distance and time is speed equals distance over time. And here are the values of d and t rounded. Work out the upper and lower bounds for s. So we're going to start off by working out the upper and lower bounds for d and t. So the lower bound for d is 155. Remember, d's been rounded to two significant figures. Its upper bound is 165. T's lower bound is 7.15. Its upper bound is 7.25. Now, the upper and the lower bounds for s, to maximise s, we want the maximum value of d, 165, divided by the smallest possible value, 7.15, and this gives us 23.0769, etc. The lower value of s, we're going to get that by doing this calculation. The lower bound for d, which is 155, divided by the upper bound for t, 7.25, which gives us 21.3793, etc. So the upper bound for s is 23.1 to 1 decimal place, and the lower bound is 21.4, also to 1 decimal place. Question 26. For all values of x, f of x is x squared plus 1, g of x is x minus 5. Show that fg of x is given by this result here. Fg of x is f of g of x. This is an example of a composite function. So we're doing f to g of x, which is x minus 5. The function f says square x and then add 1, or square whatever you are applying the function to and then add 1. So for instance, f of 7 would equal 7 squared plus 1, which is 49 plus 1, which is 50. F of p would be p squared plus 1. F of x minus 5 is x minus 5 all squared plus 1, which is double brackets x minus 5 plus 1, and then expanding our brackets gives us this, which is x squared minus 10x plus 26 at the end. Question 26, part B. Solve fg of x equals gf of x. Now, the composite function gf of x is g of f of x which is g of x squared plus 1. The function g says subtract 5. So we're taking x squared plus 1 and we're subtracting 5 from it, which is x squared minus 4. So this tells us that fg of x, which was x squared minus 10x plus 26, must equal gf of x, x squared minus 4. Subtracting x squared from both sides leaves us with a much simpler equation, minus 10x plus 26 equals negative 4. Add 10x to both sides, 26 equals negative 4 plus 10x. Add 4, 30 equals 10x, and then very simply divide by 10, x equals 3. Question 27. The volume of a pyramid is a third the area of the base multiplied by the perpendicular height. We have a rectangular base pyramid with a volume of 336 meters cubed, 336 meters cubed. X is the centre of the horizontal base directly below V. Work out the angle between VB and the base. So here's VB. If we drop a vertical to the ground at X and then return to B, we create a right angle triangle, and the angle we're looking for is the angle between VB and the base. It's this angle here, which we'll call lowercase x. Now, the volume of the pyramid, 336, must equal 1/3 of the area of the base, which is 14 multiplied by 8, multiplied by the height, which we'll call h. We can rearrange this calculation and simplify it to calculate the value of h. 336 multiplied by 3 is 1008, which must equal 14 multiplied by 8 multiplied by h. So 1008 must equal 112h, which means that h equals 1008 divided by 112. This is equal to 9. So the height, which we'll mark on here, is equal to 9. So we now need to find the value of bx, which we can do drawing in a right angle triangle here. This point here, we'll call it M, is the centre of AB, which means that M to B is 7, and X to M is half of this side here, BX, as X is in the centre of the base, which means that X to M is 4. So we're dealing with this right angle triangle XMB, 7 and 4. So xb squared is equal to 4 squared plus 7 squared, applying Pythagoras Theorem, which is a total of 65, which means that xb is equal to the root of 65, which we're going to leave as an exact form, root 65. So if we look at the right angle triangle, VXB, this is the angle we're looking for, lowercase x, Vx is 9, xb is root 65, then we can see that we have the opposite, the adjacent, and the hypotenuse. We're dealing with the opposite and the adjacent, so this question is related to tan. We know that tan of x is equal to the opposite divided by the adjacent, so tan of x is equal to 9 divided by root 65, so x is equal to tan to the minus 1, the inverse tan function of 9 over root 65, which comes to a value of 48.145, etc., or 48.1 degree to 1 decimal place.